determine the whole or wholes of the function and graph. So we have f of x equals x squared minus 9 over x minus 3. How am I going to determine the whole or wholes of this function and then graph it? Chloe is here with her latest cheat sheet notes. She wants you to know that if you are trying to figure out if your function has a whole, first simplify your function. Then take the original denominator, set it equal to 0, and solve. Then plug this answer into your simplified function. Now that we have Chloe's cheat sheet notes, let's go ahead and determine the whole of this function and graph it. Now, the first thing that Chloe let us know if we're trying to figure out if our function does have a whole is to simplify the function. So we have f of x equals x squared minus 9 over the quantity x minus 3. I can see that in my numerator x squared minus 9, this can be factored down a little bit more. Now, x squared minus 9 is the same thing as x squared plus 0x minus 9. 0 times x is 0, and that's what we don't have to put the 0 here in the original. So I'm going to add the 0x in because this helps me on my next part. What two numbers multiplied by each other will give you negative 9, but added together will give you 0. The answer to this is x plus 3 and x minus 3. And we can go ahead and do our FOIL technique to see that it's the same thing. X times x would give us x squared. X times negative 3 would give us negative 3x. 3 times x would give us a positive 3x. And 3 times negative 3 does give us the negative 9. So you can see I went ahead and wrote it out here, same thing, and negative 3x plus 3x in the center, that actually ends up being 0x, and we can take out that 0x, and you can see that x squared minus 9, it's still equal. So when we are factoring out our numerator, we get x plus 3 times the quantity x minus 3. So we are still on the first step, which is to simplify your function. We just found out that our numerator will be the quantity x plus 3 times the quantity x minus 3, and that this is all still over the same denominator of x minus 3. Now I can see that both of these have the quantity x minus 3, so I can cancel those out. That will leave me with the quantity x plus 3 in the numerator and 1 in the denominator, which is the same thing as x plus 3. So now we have simplified our function as far as we can. F of x equals x plus 3. Now the next part here says to take the original denominator, set it equal to 0, and solve. So our original denominator was x minus 3. We will go ahead, set that equal to 0, and solve for x. We'll start by adding 3 to each side, so the 3's will cancel out on the left, and we end up getting x equals 3. Now the next step is to plug this answer into our simplified function. So when we took the original denominator, set it equal to 0, we got x equals 3. Now let's plug it back into our original equation, our reduced original equation, which was f of x equals x plus 3. So anywhere there's an x, I'm going to put a 3. So f of 3 equals, instead of x, we'll plug in our 3. 3 plus 3. So our f of 3 equals 6. What that means is when our x is equal to 3, our y is equal to 6. That right there is our whole. So our whole for this one is the 0.3, 6. Now, if we were going to go ahead and graph this, the first thing I would have done is I noticed that f of x equals x plus 3, that's in slope-intercept form, y equals mx plus b, where my m is the number in front of the x, which is 1, and my b, my y-intercept is 3. So I went ahead and plotted a point right here at 3, and then my slope is 1, so I go up 1, right 1, up 1, right 1. And I get a few points here, and then what I can do is just draw my line straight through there. Now I have a hole at 3, 6. So at 3, 6, notice there's an open circle right there. That hole is not actually, there's nothing for your function that goes through that point. So that's why it's called a hole. Then we can just get rid of those original points, and this is how I would graph my function.